With the concepts that we've talked about, we can answer questions like this. Say I have a 3.25 carat diamond. A diamond is a solid that is composed entirely of carbon, the element carbon, which is number 6 on the periodic table. And it is the structure of it looks a little bit like this. So this is kind of depicted here. And we can answer questions like, well, in this 3.25 carat diamond, how many moles of carbon are there, and how many carbon atoms does that correspond to? So let's go through this example of how we can actually use the idea of a mole and molar masses to answer questions like how many atoms are there in this diamond. So our first step is to convert our carats to grams. So we know that 1 carat equals 0.2 grams, so we could practice some of our unit conversions here. So let's start. 3.25 carats. We know carat needs to be in the denominator, so that's going to be in the denominator our unit conversion, and our 0.200 grams will be in the numerator. All right, and this will help us figure out how much. All right, so 3.25 times 0.2, 0.650. We'll do 3 sig figs here because we got 3 sig figs in both of our things that we're multiplying. So that's the mass of our diamond. And now the first question is, how do we get to moles? And here we're going to need to use the molar mass. And specifically, we'll need it for carbon since we know that's what this is made out of. And so we'll need to look this up in the periodic table. I happen to have it right here. Carbon's over here, number 6. And we can see 12.011. We'll use more sig figs than we did in our previous example. All right, so 12.011 grams per mole. Okay, and so we can think of this as another unit conversion, converting from the unit of grams to the unit of moles. So we need to take 0.650 grams. And again, looking at our value here, we need the unit we want to cancel, in this case grams, to be in the denominator. So that means our 12.011 grams needs to go in the denominator, and our moles needs to go in the numerator. We often abbreviate moles, we just drop the E and write it as a 3-letter word. You'll see me do this all the time. Most chemists do this. It's just an abbreviation we use. I don't know. One letter makes all the difference, I guess. Anyway, we can go ahead and do this calculation here. Pull up my calculator again. So we have our 0.650 times 12.011. Sorry, not times. That needs to be divided by. And we get 0.0541. moles of carbon. So that is the amount, the number of moles that is in this diamond. Now, how many atoms does that correspond to? So that's the next question that we can answer. And here we're going to need to use the number of particles that's in a mole. And one thing I forgot to mention, this has a specific name. This is known as Avogadro's number. Amedeo Avogadro was an Italian scientist who pioneered the idea of a mole. So Avogadro's number, and that is often written as capital N lowercase a like this. And just as a reminder, I had it earlier, but 6.022 times 10 to the 23rd. That is Avogadro's number. So we're going to need this to go from moles to number of atoms. So we know we have 0.0541 moles of carbon, and we need to divide by moles. So in every 1 mole, there is 6.022 times 10 to the 23rd atoms to get to the number of carbon atoms. Now, how did I know to put it this way and not the other way around? Well, I know that moles needs to go in the denominator because moles is here, and I need these to cancel out. And so this here, this fraction here, we could flip it around and have atoms on the bottom and moles on the top if we need to go the other way around. So this is, again, another example of basically this is sort of a unit conversion. We are just converting from moles to atoms using this known, these are equal to each other. 6.022 times 10 to the 23 atoms is a mole. Those are equivalent quantities. Okay, so we can again plug that into my calculator. So we have our answer there. I'll just multiply this by 6.022 times 10 to the 23, and that gives us 3.259, just rounding, times 10 to the 22. That's this E22 on the end. So 3.2, we'll round it up to 3.26 times 10 to the 22. And there we have it. It may at first have seemed like an impossible question to answer. How many atoms are in a diamond? But using the tools of moles and molar masses, we can actually answer that question, which is really cool in my opinion. And it's a lot of atoms, 10 to the 22 atoms, right? If we actually wrote this number completely out, I think I'll just go ahead and do that for fun. Feel free to speed up this part of the video, because it'll take me a little while. But right, there's a lot of atoms in just that small diamond, right? So it's 3, 2, 6, and then I need to write 20 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that should be 3.26 times 10 to the 22 atoms. You can, number one, see why scientific notation is so useful. This was a pain to write out. But this also, I think, hopefully illustrates, we're talking a lot of atoms in just even a very small diamond, right, that only weighs like a little over half a gram. But a mole allows us to count this without needing to keep track of all these 10 to the 22, 10 to the 23. It's much easier to say that's just 0.05 moles. So it's just a lot simpler to do. So this is one example of how we can use the idea of moles, molar masses, to be able to figure out how many particles is in something, how many moles is in something based on a mass.